Firefighters risk their lives to save others daily. In the UK, they get called out to nearly 1 million fires or false alarms every year. Fortunately, this is just an exercise. Today's Maths for Real is all about angles and right-angled triangles. Now, it's absolutely crucial for the firefighters that they get the angle of their ladder just right.
From the side, you can see that the building, the ground and the ladder make a right-angled triangle. And for firefighters, it's this angle here that's the critical one.
When the fire service arrives at the scene of a fire, it's really important that they react quickly, knowing the safe and correct angle for the ladder has to become second nature. Now, the rule of thumb is that the distance from the bottom of the ladder to the base of the building has to be 1/3 of the working height. Now, the height the ladder reaches up the wall is its working height, and if that's 9 metres, that means that the distance from the building to the bottom of the ladder should be 3 metres. And if we measure that with our protractor, thank you, Mr. Natman, we can see the angle is 71 degrees.
This diagram is a similar triangle to the one made by the ladder. The sides are much shorter, but they're in the same proportions, so the angles are the same. This angle here is still 71 degrees. Exam questions are full of examples with ladders, but before we start tackling some questions, here's a reminder of some right-angled triangle terminology.
This is a right-angled triangle because this angle here is 90 degrees. The side opposite the right angle is the longest side of the triangle and it's called the hypotenuse. The angle you're working with is usually labelled with the Greek symbol theta. If this is theta, remember this is the hypotenuse, the side next to me is the adjacent, and that side over there is the opposite. Change the angles round. And this is now theta. This is still the hypotenuse because it's the longest side of the triangle, but this is now the adjacent because it's next to the angle theta. And over there is the opposite side because it's opposite the angle theta.
Remember, this is the symbol for a right angle. Either of the other two angles can be called theta. What ancient mathematicians discovered was that for a given angle, the ratio of the opposite length divided by the hypotenuse length was always the same. Confused? Well, keep watching.
Back to our ladder example where the angle is 71 degrees. The length of the opposite side, which is how high the ladder reaches up the wall, is 9 metres. The length of the ladder, which is the hypotenuse, is 9.5 metres. So the ratio, opposite over hypotenuse, is 9 divided by 9.5, and that equals 0.95 to 2 decimal places.
In this scale drawing, the angle is the same. It's still 71 degrees, but the sides of the triangle are much shorter. The length of the opposite side is 60 centimetres, and the length of the hypotenuse is 63.4 centimetres. But the ratio, 60 divided by 63.4, is the same. It's still 0.95 to 2 decimal places. For any right-angled triangle, the ratio of the opposite divided by the hypotenuse is known as the sine of the angle theta, or sine theta for short. And you can use this equation to solve maths problems. Exam questions are often about ladders against walls. A typical question is, if a ladder is set at an angle of 65 degrees to the ground and the length of the ladder is 15 metres, what height will it reach? Here's the triangle. This is our angle theta, which is 65 degrees. The length of the ladder is the hypotenuse, and that's 15 metres. And the height that the ladder is going to reach is the opposite, and that's our unknown. This is where we need to use the sine equation. Remember, sine theta equals opposite over hypotenuse. Put in the numbers we've been given, and you get the sine of 65 degrees equals the opposite divided by 15. To solve this, you need to get the opposite on its own. Multiply both sides by 15, and you get 15 multiplied by the sine of 65 equals the opposite. It's the same as opposite equals 15 times sine 65. To work out 15 multiplied by sine 65, you need to use your calculator. Now the trick here is to know how your calculator works, because not all calculators are the same. On my calculator, I need to key in 15 multiplied by sine 65, which is 13.6 to 1 decimal place. So the height the ladder will reach is very nearly 13.6 meters.
"19-year-old Rachel Crossland is one of the UK's top female water skiers. Her best jump is 37 metres, just 7 metres short of the world record for under 21s. Is it daunting going off the end?
It feels high, especially when you're coming up to it and you can see how high it looks. Yeah.
And when you're flying through the air, is that really weird?
No, it feels really good when you're flying through the air.
Tell me, competition-wise, do the specifications of the ramp change at all?
No, they never change. They're always crucial to be at the right angle and the right height.
So what are they?
The height of the ramp's 1.6 metres and the angle's 14 degrees.
That never changes?
No, never.
The length of the ramp is strictly governed by mathematics. Now, if you have a look at the ramp from the side, you'll notice that it forms a right-angled triangle. The angle theta that we're interested in is the angle of elevation, this one just here, which Rachel has already told us is 14 degrees. We also know that the takeoff height over here is 1.6 metres, and that is the opposite. So if that's the case, what is the length of the ramp? Or in other words, what's the length of the hypotenuse? Remember, the basic sine equation is sine theta equals opposite over hypotenuse. For this problem, theta is 14 degrees, and the opposite, that's the height of the ramp, is 1.6 metres. Sine 14 equals 1.6 divided by the hypotenuse. Rearrange the equation, and that means the hypotenuse equals 1.6 divided by sine 14. You'll need to use your calculator to work it out. With my calculator, I key in 1.6 divided by sine 14, and that equals 6.613704791. But to 1 decimal place, that means the hypotenuse equals 6.6 metres, or in other words, the ramp is just over 6.5 metres. That's the maths done, but I think I'm going to need a few more lessons before I finally crack the water skiing.
It's that part of the programme where Ben and I have to do some maths for real. We've both got to tackle the same question, but only one answer will be right.
The other will contain a deliberate mistake that you've got to try and spot, so watch carefully and decide if you'll tick it or trash it.
A right-angled triangle has an angle BAC of 62 degrees and a length AC of 18 centimetres. Calculate the length of BC. Lids off, are you ready?
Ready.
Go.
A right-angled triangle has an angle BAC of 62 degrees and a length AC of 18 centimetres. Calculate the length of BC.
The equation to use is sine theta equals opposite over hypotenuse. Then substitute the information we already have. The angle theta is 62 degrees. The opposite is this side here. That's the side opposite theta, which is BC. And the hypotenuse is this line here because it's the longest side in the triangle. So sine 62 equals BC divided by 18. Now to find BC, you've got to multiply both sides by 18. And when you do that, you can see that both of these 18s will cancel out. And you're left with BC equals 18 multiplied by sine 62. I worked it out on my calculator and it's 15.89305667, and I'm going to round that up to 15.9 centimetres.
I used the same equation as Katie. Sine theta equals opposite over hypotenuse. The angle theta is 62 degrees, but I got different values for my opposite and hypotenuse. This side here is the opposite because it's opposite the right angle, and we know that that's 18 centimetres. The hypotenuse is BC because it's opposite the angle theta. So that means sine 62 equals 18 divided by BC. To find BC, I had to rearrange the equation. Now, I did that by multiplying both sides by BC. Like that. And then dividing both sides by sine 62. And then cancelling out, that meant that BC equals 18 divided by sine 62, which is 20.4 centimetres.
So, which will make the tick flash and which one's headed for the trash?
Was Katie right to say that sine 62 equals BC divided by 18?
Or was Ben right with sine 62 equals 18 divided by BC?
OK, my answer is wrong. I made a really common mistake, which is to identify the sides of the triangle incorrectly. Remember that the opposite side is the side opposite the angle theta, and the hypotenuse is always the longest side.
Tanni Gray is a top Paralympic athlete with several gold medals. But what's all this got to do with the sine ratio? The answer is ramps.
Ramps make a huge difference to everything I do. You know, steps do look nice, but rather difficult to get up and down in a wheelchair. So without ramps, I wouldn't be able to do anything.
What kind of distances do you compete?
I compete everything from 200 metres up to the marathon, which is 26 miles. But I mean, I have competed in marathons which have had something like 10 to 15 curbs in.
OK, when you actually get to ramps, is the angle of the elevation of the ramp important?
The angle makes a huge difference. I think a lot of people will put a ramp down and think, well, we've got a ramp, so that's great. But if the angle's too steep, then you just can't get up it.
The angle of the ramp is really important. We've got 3 different ramps here. We've got 5 degrees, 10 degrees and 15 degrees. And Tanni's going to try them all out. Let's go for 15 first.
Ooh, that's quite hard to get up.
Is it?
You need to get a bit of speed and it's not that safe coming down.
OK, let's try 10 degrees.
Very easy. That still takes quite a bit of work to get up. Not that easy. This one looks a nice one.
This is the shallowest one, 5 degrees.
That's very easy to get up, and I think this is the recommended height for anyone who wants to build a ramp.
So what about this ramp here? We don't know the angle here, but we do know that the length of the ramp is 150 centimetres, and the height of the ramp to the curb is 20 centimetres. So do these dimensions produce an acceptable angle? Well, we've been given the hypotenuse length and we've been given the opposite length. So with those, we should be able to find this angle here, which is theta. Back to the formula. Sine theta equals opposite over hypotenuse. To work out the angle, you're going to have to use the inverse sine function, sine to the -1. Now, on this calculator, I would use the shift button and then the sine button. But it's really important you know how your calculator works, because not all calculators are the same. So, calculate theta and see if this ramp is OK for a wheelchair user.